Oops. Okay, there we go. Okay, in theory, we are live. Hey, everybody. Welcome to the virtual star party for, man, what is it? Sunday, June? Time has no meaning anymore. 2020, January,
June 7th.
June 7th, 2020. Of course, I'm Fraser Cain, publisher of Universe Today. We've got a couple of telescopes tonight. My telescope is out of commission, and I don't mean mine. It's the incredible telescope supplied by Oceanside Photo and Telescope, the RASA, in Landers, California. Unfortunately, the telescope is it's high wind speeds, 40 miles per hour, which is like 1,000,000 kilometers per hour, and so we don't open the telescope, even though the skies are clear. We don't open the telescope, but fortunately, we've got some other people here with some telescopes. So I'm going to hide myself again and introduce the people who are with us on screen right now. A blast from the past again. We've got Stuart Forman. Hey, Stuart, welcome back.
Hey, it's nice to be back.
Yeah, it's awesome. We haven't seen you for 7 years.
7 years.
Yeah.
Yes.
Oh, it's possible you and I have hung out casually in between then, but
Yes.
But in general, yeah, no, we haven't been doing these star parties for 7 years. So yeah, it's a whole new world. Let's see, we've got Roy Salisbury again. Hey, Roy.
Hello.
And how's your weather looking?
I'm good, except for a little high winds, but I'm going to chance it.
Yeah, not as bad as what I had.
No, I'm up 10, 15 miles an hour.
Yeah,
but
yeah.
Right on the edge.
That's awesome. All right, and for color commentary, we've got David Farina. Hey, David. Welcome back.
Hey there.
How are we doing?
Here in Norfolk.
And we've got Dave Dickinson. Hey, David.
Oh, okay. Hey. Here in Norfolk again.
Here in Norfolk again. Yeah, two Davids. This is going to get confusing. So let's just talk a little bit about what we've got in the skies tonight, and then we can sort of figure out what we're going to be looking at here. So again, we are still in the springtime, and I'm going to bring up my screen here to show everybody what the view is like. And this is the view from California, but which is kind of the view that Stuart's going to be seeing. So, all right, let me do this. See, that's maybe too much. All right. Okay. So this is the sky in California right now. Everyone can't see my. Hold on, I'm gonna make sure that my co-host can see my view here. Okay, you guys can see it now. All right. So this is the sky in California. So we've got some of these. We're still seeing a lot of the winter galaxies, which are great. All of the stuff in Leo, all of the stuff in Virgo, Ursa Major, Ursa Minor, all of these galaxies that we've become quite familiar with each week. They're still very high up in the sky. You can see these red dots. There's the Whirlpool Galaxy. There is the Sunflower Galaxy. If you know your Ursa Major, of course, this is the Big Dipper. There's the bottom of the Dipper, there's the handle of the Dipper, and there's all of these galaxies underneath the Dipper. So whenever you look up at Ursa Major, you can see them. And then there's a bunch that are above the handle as well. So I know we're going to be looking at a lot of those. The other thing that's starting to come up nicely is all of the summer objects are starting to show up. And where we want to look in there is we want to look into the area around Hercules. And so this is where the summer triangle starts to come up, which is Vega. And so you can see we've got the Great Globular Cluster in Hercules. We've got another globular cluster, M92. We've got another one in Ophiuchus. So we're going to see a lot of globular clusters in the beginning. And they're good because they're very bright. The thing that we aren't going to get a chance to see, and I know everybody wants to ask about this every time, is we don't get that really great... all those great nebulae that are in the heart of the Milky Way. And that's because the Milky Way, I don't know if I have something that shows the Milky Way.
Yeah, give it about another month.
Yeah, so we're still about a month away from being able to see that. So you can see right down here on the horizon, you've got some of the highest objects in. You've got the Eagle Nebula, you've got the Omega Nebula. All of this stuff is just fantastic. And once we actually get to that part of the of the year. It's just going to look fantastic. But we got to wait week after week after week as these things get higher and higher and higher. So until then, it's going to be a lot of globular clusters and galaxies. But, just remember these days, because when the galaxies are gone, you'll feel really sad, and you'll be...
And
I won't.
Yeah, there's going to be like 2 galaxies to look at. We'll have Andromeda and we'll have M33, and the rest will be below the horizon. So
there's a reason for that too. Is in the springtime we're looking kind of perpendicular away from our galactic plane, so you can see all those galaxies in Virgo, and you're looking out kind of at an open, wider expanse of space. Of course, the stars up in there are in our galaxy, but it's a much thinner layer of our galaxy you're looking through.
Yeah, and the thing that I always like to sort of mention is this idea that, we talk about how we're located inside the Virgo supercluster, which is this gigantic structure that contains all of the galaxies that's in our area. These are our neighbors. And so when they call it the Virgo supercluster, because when you're looking into the constellation of Virgo, which go out there, learn your constellations. You can find Virgo. Spica is the very bright star that's located in it. You can see all of these galaxies. Look at it as I zoom in. You can see all of these galaxies. And so we're going to spend a lot of time. Markarian's chain, M90, M89, M60, so many galaxies. And these are the galaxies that are part of the Virgo supercluster. If you were to write your address on an envelope and include a very specific list, you would include the Virgo supercluster, because this is where
Spica's another nearby supernova candidate. I know we've all been talking about.
Oh, really? Has a chance to go off.
That's also it's like in the 250 light year range, so it's a ways off too. But somewhere in the next 100,000 years or so. So
I'm seeing Boomed Yeti Lush is saying, I hope you can show M42 in Orion. We can't. No. That's a wintertime object.
Yep. Speaking of Betelgeuse.
Yeah. So here I'll show you where M42 is.
Yeah. It's like it's setting now.
Yeah.
Yeah. It's kind of behind the sun.
Yeah. Yeah. So there it is, right there under the ground. So if you could see the sun, you would see M42 close to the sun, and so that's why we're not going to.
This would be the worst time. This would be the worst time of year for Betelgeuse to erupt.
Yeah, it really would be terrible. Yeah. So the other thing that I want to mention is, of course, like last week, we're going to be posting all of our. We're going to be posting a lot of the pictures that we take tonight into a directory. And so if you're following this on the live chat, either on Twitch or on YouTube, I know that Nancy is going to be posting, or the Nightbot is going to be posting a location of the Google Drive directory. And it's publicly available. There's going to be a whole bunch of both processed JPEG images that you can look at, as well as FITS files. And those are the raw images that astrophotographers use. So if you want to get more practice and experience in working with astrophotography, you can go ahead and just go into that directory and start to play around with it. And we'll keep one of these every week. So, all right. So I don't know if anybody has so you guys are going to have to let me know when you've actually got a picture.
I'm not quite ready yet. It's not quite dark enough.
I have my M13 I can do.
Okay, let's do it. Yeah, you actually have it to share?
Yeah, I just got to remember how to do it.
Yeah. Let me know when you've got it ready to go. You got to click on the screen share.
Yeah. Where is it? There it is.
So, like I said, I don't have a telescope tonight. I've got high wind speed, so I'll have more of my brain available to actually answer any questions that you've got. But we've also got David and David here to help us. And we're going to have to figure this out. David F.
Cosmos is fine.
All right,
I'm used to it.
Yeah. Okay, great.
It.
All right.
That's you.
Perfect.
One of the better globulars in the Northern Hemisphere.
I like that you say globular. I feel like I've been beaten down to the point now that I say it wrong. So.
If you say globular, I know what you. I
know. But I feel like you have like changed the way you say it just to make me feel more comfortable. And now I have adopted the the way that everyone was beating me up. So I don't know. I feel like I'm betraying. I'm going back to globular.
It gives you that sense of three-dimensional,
Yeah,
globe.
yeah,
It's a
yeah.
globular cluster.
Globe, exactly. That's why I thought that's how you said it. And Dave,
Actually, that's very clever.
Dave,
I'm going to say globular from now on.
yeah, Dave
I've
came to my defense, and he said it's a perfectly valid way to say it. And now
I've heard rather heated debates in the dark at star parties on whether it's globular or globular before.
Yeah.
So.
and the answer
Just
is
make
yes.
sure it's dark enough they don't know who said it. Then you don't have to worry.
Yeah. Eric Briggs is saying, please give us a word on how the axial inclination is the reason for the seasons. There are a few frightened people who've noticed that the sun has moved north this spring. Yeah. Yeah. When you think about, like, every day the sun moves 1/365th through the sky. And so every day it's a little bit, and of course the sun isn't moving, the earth is going around the sun. And so we're seeing a different part of the night sky than we did the night before. And so, and so that's why some constellations are visible in the wintertime and other constellations are in the summertime. And of course, also different stuff is visible from the northern hemisphere than from the southern hemisphere. And boy, I would love to get a telescope rolling from the southern hemisphere so we can get some of that, because I literally have no idea what's up there. It could just be monsters, and I don't know.
You know what's kind of cool when you go down there is seeing familiar constellations upside down,
Yes.
like Orion or Leo. Because I've been to Australia and Kenya and a few places south of the equator.
Yeah.
And it's interesting to see the unfamiliar stuff. Like everybody looks for the large and small Magellanic clouds. Those are kind of cool. And
Yeah.
they're so far down there, you got to actually go to the southern hemisphere to see them. But some of the familiar stuff doesn't look as familiar.
Again, the thing that really struck me was being in Australia and being able to look straight up and see the core of the Milky Way, to see Saturn in the Milky Way directly over my head. It was absolutely crazy.
And to see the sun rises in the east and sets in the west like it does here, but instead of transiting to the south, everything transits to the north.
Yeah.
So,
Right.
which is kind of would throw me off down there too.
Yeah. So let's talk a little bit about David F. Do you have anything to say about globular clusters?
I've heard a lot of people discussing recently, actually, what it would be like to live in one, and I think we mentioned this last time, just how we would have such a different perspective on the universe, and how, if you lived inside of this, you would probably not even know there was much more than, stars. You wouldn't possibly even know that there were galaxies out there beyond it, or nebulae. So just to imagine yourself in one of these places and how that would change your perspective of the universe as a whole.
Yeah.
Kind of neat.
I think the average distance inside one of these is about a light year per star, and that's on average. So a lot of the time the stars are much closer than that. When you compare that to the rest of the galaxy, it's there are I think the average distance is like on the order of like 5 to 10 light years per star.
And aren't they the same age, the stars, more or less?
Yeah, so the interesting thing about globular clusters is that they appear to be these ancient relics left over from the beginning of the universe. They are as old as the Milky Way itself. And astronomers are still arguing about where these things come from. Did they form as one gigantic gas cloud in place, forming all of these stars that are just sort of buzzing around in this tight ball? Or are they the cores of dwarf galaxies that were consumed and sort of all of their gas and material was stripped away, and they're just the leftover snacks as the Milky Way gobbled up other galaxies? I like that version better, but
we see them in other galaxies also, if I'm correct. So it's not an abnormal thing. It seems to be pretty common.
Yeah, absolutely. And they're a really valuable tool for astronomers for a bunch of reasons. The one thing is that because it's believed that all the stars were formed at the same time, astronomers use globular clusters as a way to sort of measure things that should have all happened at the same time. So, for example, they look in these and they don't see young stars. They see old stars. All of the young stars are gone and have died, and you're left with the stars that have very long lifespans. So all of the hottest, brightest stars have blown up, and you're left with stars like our sun and like cooler than the sun. They're going to last a lot longer. But then the weird thing is that you see these stars that are blue and really surprising. And in fact, astronomers have only in the last few years figured out what's actually happened is that stars have actually collided with each other. And there's a term called blue stragglers. And so they behave like a very young hot star, but in a place where there shouldn't be any young hot stars. So it's very surprising to see this.
I know they're all very metal poor stars. Metals being,
because they're so old.
Yeah, they're like population 2 stars.
Yeah, Linda's in the chat, and Linda was mentioning that as well. Doug Ellis is asking, is it true that humans saw the Crab Nebula explode when it was a star?
It was in 1066, I believe. Well, there's
1054?
1054, yeah.
Yeah.
Yeah, 1054. Oh, 1066 is Halley's Comet.
Yeah.
Yeah, that's there's artwork from some of the petroglyphs down in the southwest Arizona that they found. I know that show they think depict the supernova and the crab because it shows the crescent moon and the supernova next to it, and so they think that there have been people that have observed it. Yes.
Yeah, that's amazing.
I think there's Chinese records of it as well. I believe.
Back from 1054.
Yes.
That's incredible. With the
there's actually animations of the crab that they've taken, like from Palomar, I believe it is, that you can see even from the 1950s to now that it's
you can
expanded.
see the change.
Yeah, it's changed because most objects don't change. I mean, the Orion Nebula doesn't change a lot in our lifetime, but in the case of the crab, it's so new that it is changing.
And so, just in case you wanted to see the Crab Nebula, the answer is no. It's below the horizon again. It's
Taurus.
It's in the constellation of Taurus, and that is a spring. That's a fall constellation. So we'll be able to have Taurus in October, November, and that's when we get to see things like Pleiades, and then we start to see Orion start to come up over the horizon. Fantastic.
Another image.
Yeah, absolutely. We're ready.
This one will be M12, another globular.
Yeah, you're all infected now. And you got a Starlink.
Yeah, every satellite stream
on that one.
So this is M12.
This is M12.
Yeah. So I'll show people again back to the sky here. So M13 is I really like M13 because it's one of the easiest globular clusters for us to be able to find. Globular clusters. Oh, this is going to be hilarious all night. So here is the constellation of Hercules, and you can see this is the chest of Hercules, these 4 stars. And so it's always so easy to see M13 because you could just see it by eye. Once you learn where Hercules is, and it's a very bright constellation. There's the chest. It's this kind of parallelogram. He's got his arms and legs all throwing out in all different directions. You can see. I usually attach this to it, but I guess that's the head of Draco. I always think that's like his club or something. But you essentially run a line between 2 of the stars in the constellation, and you get M13. M12 is a little tougher to find.
Yeah, I can find M13 with binoculars pretty easy.
Yeah.
Just because it's in that what they call the keystone of Hercules, that kind of not quite square. I always thought M3 is a little better, but M3 is tough to find because it's in a really vacant area.
Yeah, M3's a tough one too. So with M12, it's in the heart of Ophiuchus. So if you can find Ophiuchus, which is close to Hercules, and sort of on the way, it's like the halfway point between Hercules and the summer constellations is Ophiuchus, and then right in the very middle of it is M12 and M10, and so
up near Hercules, I always like to tell people toward Vega is an interesting what they call the apex of the sun's way. That's the direction we're actually moving. Our solar system is moving, not quite near Vega. Yeah, not quite. It's in Hercules, but it's near a star called Omicron Hercules, but not too far from Vega.
And you say that, like, that's the direction that the solar system is moving in the Milky Way as the Milky Way is turning?
Yeah, it's what they call the apex of the sun's way. It's one of those, there's nothing to see there, but it's just interesting to know that's the point we're moving at.
That's really cool, though.
Yeah,
that's really interesting. I had no idea. Yeah, and so we got a satellite trail here. So, Roy, when you get satellite trails like this, what do you do?
If it's really a bright satellite trail, I'll usually throw the sub exposure out.
Yeah.
A dim one like this, it'll stack out.
So you can stack out the bright ones as well. You just there are ways to do it.
Yeah,
I just clipping, right?
Yeah, exactly.
Yeah, but like this one, it'll out of 3 or 4 images, it'll stack out if you got it dithered good, and it'll go away.
Yeah, I mean, normally when like these are one exposure, and I don't know what your exposure is on this, Roy.
This was 60 seconds.
60-second exposure, okay. And so if a person's doing like a really nice picture, they'll do a whole bunch of separate exposures, and then they'll stack them up into one picture. And so each picture removes more of the noise. You can see this kind of like the grainy stuff in the background here, and decides on what is is the actual data. And so you can see the stars, and so the stars are the data, and the noise is just everything that's in the background. And these trails are part of the noise. And so your software, as you stack up these images, will throw out the excess noise and focus on the picture.
I can show you something that'll, as you stacking. This is the image I'm going to show you is an image from actually from last night. It's a mosaic image, which means there was 9 panes in this.
Oh wow!
And each pane was 4 frames. But even stacking, if you can see that.
Wow, that's incredible.
See down here around 4 o'clock or so. See that line going through there?
Yep.
That was a star trail.
Yeah.
And it's starting to stack out.
So, and are you actually? This is the Veil Nebula, right? This is
that's the whole complex.
Yeah, it's the whole thing. So this is actually an ancient supernova explosion that's in the sky, and most telescopes can't take this in one picture. You need multiple pictures. Yeah. So
this was nine separate images that are all stitched together.
Yeah,
Roy,
that's
what
incredible.
kind of scope are you using, Roy?
That is a 152 millimeter refractor, Explorer Scientific.
Nice. So that's like 1,000 millimeters, right?
This is about 890 millimeter focal length.
Okay, so it's reduced.
Reducer.
Okay, Fraser, I got my first M13.
Great. Okay, so we're gonna have dueling. We're gonna have dueling M13. So I'll switch over to Stuart's image, and you still got pretty bright skies there, right?
Yeah, they're getting better. So this is 2 minutes, bend 2x2, and this is a linear auto stretch, slightly auto stretched, but image that basically what you saw before.
Yeah.
No color in it because it's monochrome.
Yeah, and you can definitely see the. So this is a good example. Like, I think this is too long of an exposure for this object for you.
Perhaps, yeah. This is I'm bend 2x2, so for the next one I can try bending out 1x1 and see what happens.
Yeah, definitely on the. Can you change that in your software? That's gathering them automatically. Yeah,
and so I'm just looking, and you're right. It is saturated. So on the lower left-hand corner, you'll see K9939. That means that it is saturated.
Yeah. So if you can you zoom in? I want to sort of explain to people sort of part of the process of astrophotography.
Absolutely.
So you can see here when you look up really close, you can see in the middle there, the core of the image is essentially a big white blob, and so there's no longer any data in that. You've oversaturated the capability of the pixels on this camera, and it's just turned to this blobby white at this point.
Right.
And so generally when you're taking pictures, you want to take a short enough exposure that this doesn't happen, that you want to have it so it's not too bright, that it's sort of you're still getting some detail. So whatever is the most amount of detail that you can get, depending on each object is its own special little butterfly, right?
Right.
And so you've got to change your setup, change your methodology for each one of these objects.
Right. And so what the second glob that I'm doing right now, it's too late. It already started, but I have two more that I changed it to 1x1 binning, and we'll see if it makes a difference.
Yeah.
This is not a setting I ever image at, honestly, because because you can see that you can't. It gets a little blocky, and you really can't see. And it's just too sensitive. But I figured for the star party, since we're only doing 2-minute images, that I would go ahead and make it a more sensitive setting.
Yeah, and the thing I like, so Roy, you're at home comfortably operating your telescope from the middle of Arizona, and Stuart, you're in your you're in your driveway with your telescope right behind you. We can actually hear it moving around as you go. That's awesome.
So before we were on live, Roy, you were talking about like if you could redo it today, you might simply not have an observatory in Arizona, though. You think you might have it at your house?
I would. I mean, there's the filters that they have for cameras now for light pollution. I mean, even for color cameras,
it's a little better.
Are so much better than they were 10, 12 years ago. I mean, I can get a triad or quad filter for a color camera that'll allow me to photograph deep sky objects in heavy light pollution. I mean, I've seen photos from people from still in New York.
We've seen people do things from their driveway in suburban areas that are actually pretty good.
Yeah. There's one astrophotographer that I follow. He does his work, from downtown Manhattan, from his apartment in Manhattan.
When I was playing with that Stellenoscope here on the roof, and I'm in downtown Norfolk, and it's extremely, I mean, you can barely see down to third magnitude here, but you could pull out M51 and some of the brighter, messier objects with it. So.
Yeah.
Okay, I have M3 up, and it's better. You'll see
that's
that
great.
You'll see that it's a dimmer globe. It's a dimmer globe, and you see a satellite trail going through it. But the max saturation at the middle, it's still getting up to 0.6, 0.7, but it's not 1.
Yeah, no, that looks really good.
We see some more detail, and this has been 2, and then one I'm getting now is binned at 1.
Yeah.
M3
and so you can see
favorites.
like why astronomers were so angry about Starlink. The fact that we're about to get thousands and thousands and thousands. I mean, right now there are a few hundred satellites that will leave a trail in one of your images, and Starlink alone I think they're going to start with 12,000, and they've asked for up to 30 or 40,000. So I mean,
they just did launch number 8 last week, and so it's 60 times 8 satellites. They call it Starlink 7, but it was the 8th launch.
Right. I guess they're calculating it by
European floor, elevator floors.
And so it's just going to get worse. And so we're going to have multiple, like each one of these images is going to have multiple star trails running through it. And this is the price that we pay for bringing internet connectivity. The latest batch that just went up, though, does have
VisorSat.
The VisorSat, so they've got one of the Starlinks actually has a way to block off the light.
There are satellite watchers worldwide trying to track VisorSat right now.
They have to wait, though.
I have a solution for all of this, guys. You know that, right?
No.
The solution is easy. Elon has to put telescopes on every Starlink satellite and give us free access.
Right.
Space telescopes for everybody.
Yeah.
I'll be happy.
He said that. He actually promised me personally that he would do that.
On Twitter, I saw that.
On Twitter, yeah. So about a year ago.
I feel bad for like us astrophotographers, but I feel way worse for the radio astronomers.
Yeah, that's a much worse problem. They realized when they first started to launch some of these big satellites, some of these are so powerful they can actually destroy the radio receivers of various satellite, like various radio
Oh, wow, I didn't know that.
telescopes. And so they had to work out a way to make sure, like some of these, but they were like Earth monitoring satellites, like some of these big scientific Earth monitoring satellites that are beaming really powerful radar and radio down at the Earth, and they were finding that they were damaging radio telescopes, and so they've had to work through this. But yeah, they're screaming. I mean, in infrared, they're hot. This is the problem with trying to paint these Starlinks black, is they are very hot. And so, if you paint your satellite black, then it heats up in the sun, and then it's a big blob in infrared. So no matter what you do, got a question earlier from Doug Ellis. Can we view the International Space Station?
Moves too fast.
So in theory, we can, but it would take a very special telescope setup. But I'm in talks with Dustin at Oceanside Photo Telescope to try and figure out a way that we can actually do it.
There are amateurs that are imaging it. I've imaged it. Yeah, you would need more like a planetary webcam setup where you're doing several frames a second.
Yeah.
And you would have to just you can either manually track it or have a sophisticated program track. But when it comes over like an airplane would come over, so you've got maybe 5 minutes above
some of the
horizon.
The new direct drive mounts are capable. They can slew fast enough, but the cheapest direct drive I think is the Hobum right now at about 3,000. But that's, on paper at least you can track with satellites, and the bigger like PlaneWave and stuff, they can track along with a satellite. That's the purpose of those.
Yeah. So hopefully we will have that ability to do the International Space Station. That's the dream. If we can get there, I will feel like
I used to do it a very low tech way and just kind of like run video and manually aim as it came over. And so when you watch the video back, it would be nothing. Oh, there it is, nothing. But you would grab enough frames to see it.
People have taken like the space station, and you can see it transiting across the sun or the moon or whatever.
Yeah.
That's another way to do it.
Is to get one of those transit while a docking is happening.
Yes.
Yeah. Thierry Legault has done that before.
One of the benefits of tracking along with it, though, is you can almost treat it like planetary imaging, where you're taking a lot of frames and then you can stack the image. So I'd love to see a really high quality tracking of the ISS that you can then turn into a higher quality photo.
So you shifted to M92?
This is M92. Yeah. So this is my Bind 1.1.
Yeah, that's nice.
And that's better, obviously.
Can you make the picture bigger on the screen though?
Sure.
Yeah. Take up all the screen.
All the screen.
Yeah.
All the screen things. Let me see if I can.
This is a nice one in Hercules too, and sometimes it's overlooked, but it's a nice.
Yeah, I mean everyone focuses on M13. M13 is the crowd pleaser, but here I'll just show you where M92 is in relation.
This is about as big as I have a small screen. It's about as big as I can get.
Yeah.
Stuart, where are you located again?
San Francisco Bay Area, East Bay.
Okay.
Yeah. So here's M13, which we showed you before, and then here's M92. So if you can sort of, it's twice the height, I guess. It's the exact same height as the rest of the constellation. That's why I always sort of remember it. And it's like halfway in between. So you run a line bisecting the object about the height of it. You get to M92.
It's about 27,000 light years distant. A little further than M13, but not.
Yeah.
M13's like in the 22,000, I think.
Yeah, that's beautiful. Yeah, that's definitely from here on out, just bin one by one.
Yeah, for the globs, absolutely.
Yeah, for those guys. Beth Johnson is asking, what does bin mean?
Well, the a camera sensor has a bunch of pixels, and they're photosites actually is what they are. And so each photosite is a sensor, and what you can do is if you bin at one, that means you're binning you're taking using the data from each individual pixel. But if you bin 2 by 2, it means that instead of using 1 pixel, it makes a little square of 4 pixels. So you get 1, 2, 3, 4. So 2 by 2, and so you get lower resolution, but it's higher sensitivity.
Right.
And bin 3 by 3 is like you get a pixel of 9, and 4 by 4 would be a pixel of 16. So right now, instead of using one each pixel, I'm using a box of 4 pixels.
Right. And so the images look a little blockier, but you can get a fainter object to show up more quickly. And so in our situation,
which is the goal of the virtual star party. Because
is that a little galaxy? I think I see like a little galaxy.
There is near M92. It's a smaller NGC.
Let's see.
Just a little up and to the left.
This little guy?
Yeah.
Yeah. Zoom in on that. Oop. See if we can find it.
I do recall. Yeah, it's a fainter. It's fainter than 10.
I know there's one near M13 as well.
There's a little guy right there.
Yeah. That's great.
I have one up for you. If you'd like.
Let's switch over. That's awesome. Ooh,
nice.
What do we got, Roy?
This is what was it? NGC. What is it? 5907. It doesn't have any fancy name as far as I know. It's
called the Knife Edge Galaxy.
Is it? Okay.
Mm-hmm.
It's not the best one that I will show you tonight, but it's the first one.
Mm-hmm. No, it's beautiful. I've never seen this object before, so I'm super stoked that you were able to find this.
What kind of scope are you using?
A refractor.
What size?
152 millimeter. It's about a 890 focal length.
Okay.
I've got a reducer on it down to about 5.6.
Okay.
Roy, when you have it all the way in Arizona, so how often do you have somebody that helps you keep like maintenance of it, or does it need no maintenance?
I do it, but it almost needs no maintenance. I'll go out there every couple of weeks or whatever to, make sure there's no cobwebs in it, but
chase the coyotes out.
Yeah. But I mean, it's entirely self-contained. It's all off the grid, solar powered, everything.
Do you have how do you take, I know we're getting into the weeds here a little bit, but I was wondering, do you take flats and do you have that all automated?
Yep. It's all, I have all the flats, all the darks, all the bias here at home.
Okay. Wow.
Secret Scientist is saying, can we see NGC 3242? So let me just see where that is.
Yeah. Can we? I don't have my...
Yeah, so I'm just going to check to see if it's a thing that we can see.
Because I can... if we can, I can...
That's the Ghost of Jupiter.
Yeah, we had that a while ago.
Yeah, unfortunately, it's too low now. So it's starting to fade week after week from this point. So I think
that's often Hydra. Yeah, it's a planetary.
Okay. It's not going to rise. No, so it's done. Yeah, it's going down.
I have a planetary later if we stick around long enough. I have Owl Nebula later.
Oh, great. And then I think earlier on, Sergusi was saying, would we be able to see Jupiter and Saturn? No, unfortunately, because we're all in North America.
We need Corey.
Yeah, we need Corey in the morning, so we won't be able to see it until Saturn and Jupiter. They won't be rising. I'll show you here again.
They both reach opposition in mid-July, so they're going to start moving into the evening in about a month.
So here's Jupiter just below the horizon, and here's Saturn.
Mercury's out in the west right now, but it's
just below the horizon.
Pretty low, yeah.
And here is Mars, even farther below the horizon. So,
come summer and fall, all the planets come back to the except Venus. Venus is now in the morning. So,
Boomed Yet Lush is saying, any chance of the Ring Nebula? Yeah, that's on the list for tonight. I'm pretty sure. Stuart, you punched the Ring Nebula into your list. Right?
I didn't, but I can. I will. Let me.
Yeah, the Ring Nebula is a crowd pleaser, and we'll get it every week from here on out.
one of the things I find is helpful for me when I'm outside, if I'm just trying to do visual observations, is just trying to think about, how much motion you're going to have over a certain period of time. And, approximately like the width between your thumb and your pinky at arm's length is like 15 or so degrees, which is equal to the movement of the Earth's rotation every hour. So, if I know it's behind a tree or something like that, it's helpful to know that, as the sky moves above us, that within about an hour or two, I'll be able to view that object, and I can kind of plan my night out. If I'm doing visual, or if you're in the driveway like Stuart is, it's behind a tree and you want to take an image, you're going to have to wait, a certain amount of time till you can do that. So that little trick of holding your hand at arm's length, you get like 1 degree, 5 degrees, 10 degrees, and 15 degrees. And it works pretty well for most people.
Yeah. Yeah.
It's weird that the human body was built to measure the sky.
To perfectly measure the distances in the sky. Even like one finger, I think, is a degree, right? Or two fingers is 3 degrees.
Like a hand, open hand is 10.
Yeah.
Hey, Fraser, I'm going to let you take this one because this is one of your favorites.
Oh, please.
Ooh, I see the Hamburger Galaxy, I believe.
Oh, meh.
Meh.
So that's the Leo triplet.
Yep.
Yeah.
With another satellite trail.
Yeah, and you can see a little star movement. I must have had a little wind or something like that.
Yeah.
And, oops. And so you can see. And actually, this is sort of interesting. So when we look for this,
can you rotate it?
Yeah.
Can you
Sure.
rotate it 90 degrees so people see why I say meh?
Meh. Yeah. Let me. Second process. Fast rotation.
Pix Insight.
I gave up on this last week.
There we go.
There you go.
Meh.
Meh.
Yeah, you can see the meh when it's rotated that way.
Yeah. I love this. I love this group. So this is the Leo triplet. And so again, I'll give you, I'll sort of show you where this is. Again, if you can learn the constellation of Leo.
And if you look at this, you see that this is a sub I would normally throw out because you see the start, something knocked, jiggled the scope right there.
Yeah. The Leo is another one of those constellations that you should definitely learn if you don't know it. It looks like this backwards question mark in the sky, and then you can see the sort of the flank of the actual lion. So it really looks like the constellation that it is. And then the Leo triplet is sort of right there, and it's 3 galaxies. Which is it? The Hamburger Galaxy is one of them? No. No, that's a little off to the side. Yeah, okay. So
Kind of a good way to remember it. I never really thought about it, but there's those 3 stars, and it's the triplet. So it's right next to that right angle triangle there.
Yeah. I love this, but I love this this collection of galaxies. Again, like when galaxy season hits, it's like it's galaxy, and then it's gone again, and then we have to wait another year to see all these galaxies. Tree Farm says, I'm in the southern hemisphere. Can I see the Andromeda Nebula galaxy? Yeah, that's one of the few galaxies that you actually can see from the southern hemisphere is Andromeda.
If Tree Farm is in the southern hemisphere, tell Tree Farm to get a scope and start sharing the southern hemispheric images with us.
Well, the problem is that it depends where Tree Farm is, but if they're in Australia, then it'll be the daytime.
Yeah, it's true.
Yeah.
Yeah, the Hamburger Galaxy is the mouth in the diagram, the fainter one at the bottom.
So that's the Hamburger. And so like that is you're seeing that galaxy. It's actually a fairly big galaxy. You're seeing it edge on. So we're actually seeing down. If you look at that picture, you can see, and it's actually, this is great. You can really see sort of the surrounding gas around the core. And then you can see the dark dust lanes in the core of the galaxy. And so there is zoomed
in on it. So you can
see there is galaxy there. It's just being obscured by all of this dark star forming region. And this is what we have in the center of the Milky Way as well. We can't see parts of the Milky Way, not because there's nothing there, but just because there's all this material that's obscuring our view.
That one just got away from Charles Messier too, because it's NGC 3628.
Yeah, so he never gave that one an official number, but
he just never happened to spy it. He didn't record it. So there's another triplet there with 105, 95, 90. Leo's got a couple interesting galaxies in it.
Yeah. Roger Wilco saying Magellanic Clouds, please. Yeah, that would be great. I would love to.
We need somebody down south.
Yeah, we need somebody in South America. That's the key. We need somebody who is in our
I
same
have
time
a
zone.
supernova.
Oh, right on.
Oh, M61.
One, yes.
Yeah.
All right.
Yeah, it's still there. Is that hasn't faded away yet?
It's still there.
Yeah, I see it.
So it's this. You see my cursor? This guy right there. That's the supernova right there.
No, I think it's the next one.
No, I think
is that the one? Okay.
Yeah,
okay.
this is it. Right
okay.
There. Yeah.
I know it's the end of three in a line, kind of.
Yeah, yeah. So
it doesn't seem to have faded much at all. It's
no, we've been taking a picture of it every week, and there it is again.
Well, maybe it's. I thought it was this. I thought it was this little dude right there, but maybe it's this guy.
Yeah, we'll have to wait till one of them disappears, and then we'll know for sure.
Yeah.
Is it normally like 2 weeks of a good peak, and then it
I think
starts to peter off?
Hopefully nobody's civilization's getting wiped out for entertainment.
So the interesting thing about M61 is that it's a supernova factory, and there have been several supernovas over the last 20 years in this one particular galaxy. And this is just, I think this is just obviously the most recent, but they're they happen once every few years in this galaxy. And you can see some other little galaxies in this view as well. So you see a little guy there, and a little guy there, and a little guy there.
Yeah, yeah.
And a little guy over here.
And so do we know what kind of supernova it is? It's 2020 JFO, right?
JFO, I think, yeah.
Yeah.
I remember looking it up too. I want to say it was Type 1A.
It looks like it's a Type 2.
100% Type 2.
Yeah, it's a Type 2 supernova. So the Type 1A supernova, those are the ones which are like a white dwarf star that's gobbled material from a companion and then they explode. The Type 2 are the core collapse supernova. There's a few varieties of those, but...
And the Type 1A are the ones that are best used for distance measurement.
Standard candles.
Yeah. They explode with the exact same amount of energy. So we believe right now. While the Type 2s can be different amounts of energy depending on the size and mass of the star that created it.
So, Stuart, you were saying that this particular galaxy is one that's produced a lot of supernova. I mean, are they within the same region of the galaxy, or are they spread throughout the galaxy? My question, there's this thing called a galactic fountain, where a supernova triggers surrounding other supernovas. Is there a proximity thing here?
I'll tell you, when I was looking at the supernova and I was trying to figure out, okay, which of these stars is a supernova, I was looking at an image that had a supernova, but it didn't look like my picture. But I thought it was a supernova, and it was like one from like 1999. And the supernova that I saw there, it took me like a while to figure out, oh, this is the wrong one, was like in this area here, where my cursor is.
Right.
And so I think it's probably in different areas of the galaxy.
Yeah, so there's been 8 supernova in this one galaxy that have been observed so far.
Looks like it's a very tight barred spiral too.
Yeah. Are there any galaxies undergoing collision within view?
Well,
tonight?
M51, I know you're going to get a picture of M51 later on.
Yeah, it's a little later. Yeah, I got it.
Yeah. And that'll do that.
Hang on.
So
I have a galaxy for you.
All right, here we go. This is perfect. This is smooth. Oh, look at that.
Oh, cool.
That is so great.
That's a little low for me. I can't get at it.
So that's the sombrero.
Right on the edge.
Yeah, an even better example of looking into the core of a galaxy. You can see those dark dust lanes.
M104, yeah.
Yeah. Roger Wilco is asking, how close are the galaxies of the Leo triplet to each other? Would they look? I wonder how they would look. I don't know how far away they are.
They're probably well, they're 35 million light years.
Yeah.
From us, but I would say they're probably a million or so light years
from each other.
apart.
Yeah.
I know the NGC one is 45 million, so it's probably a little further in the background, like maybe by 10 million light years. Yeah. They may be on the order of, like, say, our distance to Andromeda or something like that.
Yeah. Yeah, I love the sombrero.
Okay, I've got part of Mercurians.
Oh yeah.
With some star trailing here, but we can still see it.
Okay, hold on. Let me just switch over to your screen.
Yeah.
There we go. Oh, that's fantastic. Look at that.
Here.
Yeah.
I find it interesting to think that we humans are actually over halfway in the scale of, like, the whole universe, including the very smallest things like quarks and the smallest things compared to the galaxies. We're actually more towards the side of galaxies in terms of our scale than we are the smallest things.
Yeah.
Weird to think about.
Yeah.
We have more in common with a galaxy than we do with a quark in terms of our size.
That is
that is pretty.
Yeah, if you take I did this video a couple of years ago talking about, this famous saying that there's more stars in the sky than there are there's more stars in the Milky Way, I think, or no, stars in the universe. There are grains of sand in all the beaches on all the world. And it works if you just go with all the beaches. It doesn't work if you go with all the sand on the Earth. It's way more sand on the Earth than there is grains of there's way more sand than there are stars in the sky. But if each star was the size of an atom and you took all of the stars in the entire observable universe, they would be less than a sugar cube.
Wow.
So it shows you just how small atoms are.
And atoms are big compared to a lot.
Yeah, more fundamental particles. So, so Markarian's chain is great. So again, we're just like back to welcome to galaxy season. So, it is, and it's kind of hard to say where Markarian's chain begins, and where it ends.
There's a couple bright Messier ones in the chain because for my book I filtered down to 10th magnitude. So some of the galaxies in the chain didn't make the cut.
Yeah.
But M86 I think is the brightest one.
And so you can see here.
M84 and M86. Yeah.
Yeah. So
M86 I think is the brightest one in Markarian's chain.
So I'm zoomed in right now, and you can see why they call it the Markarian's chain. So you've got all of these galaxies, just galaxy, all the way along, and just in this big long chain. And so you actually, to get the full thing, you'll need to take multiple images. There's more galaxies up here.
Or a wide field
that
telescope,
might be,
which I do not have.
That would be another awesome thing to do sometime, Roy, is try to just get all of those galaxies. Have you tried to do that, like what you did with the Veil Nebula, but just go after all those galaxies?
No, I haven't, but I will.
I saw somebody did a great picture of that, where they just took a picture of the constellation, like of the Virgo constellation, and had all those galaxies, and then did little insets of all of the different little galaxies. They'd done close-ups, but also just that big wide field. It was a really powerful image to show you that.
The Veil one that I'm doing it's going to be my first big mosaic. If I can figure out that one and I can get it working right with all three narrowband channels, then I'll branch out.
That's great. Boomed Yet Lush is asking why the trails in the image. So Stuart, why do you have these trails in your image?
Because I had a wind gust. It's kind of windy here.
Yeah.
And so anytime the scope jiggles a little bit, then you'll see those little lines. And normally if I were actually imaging this, I would just throw this one out and just go to a different one, which is why we do multiple different images of the same thing, because you're going to get, somebody knocking, a little vibration, a little wind, whatever,
And so this is, I mean, when you see those pictures on Astronomy Picture of the Day, right, these beautiful images, the astronomer has taken sometimes dozens, sometimes hundreds of hours of data to gather that picture. They've looked at every single image. They've thrown out every one that they are not happy with. Right. It's the end result of a tremendous amount of work.
Yeah, usually my image is like a completed image. I did one of the Cocoon Nebula that was 30 hours of data.
Yeah.
And this is 2 minutes of data, you know, so it's, you know, but it's just interesting that in 2 minutes you can actually see quite a bit.
Yeah. I know. I feel like that's the, one of the things that, you know, my impatience has helped the astronomers that I get a chance to work with to realize that, in fact, it's kind of surprising how good of an image you can take so quickly. Secret Scientist asked if M64 is viewable, and I think we'll be able to get that. I'm sure that's on someone's list.
What's
that's
I'm doing
black,
it right now.
That's the
this
black.
Is it.
Oh, that's
I
what
got
you're
it
doing. Okay,
I got it right now. It's right there.
Oh, there you go. Perfect. Ask and you shall
Ask
receive.
And you shall
Secret
receive.
Scientist. Yeah. So there's the Black Eye Galaxy, M64.
It's like, God, I could have sworn I have it.
Yeah, but it might be on the list. Oh wait, it's the thing that I just put on the screen.
Yeah, and it's called that because you see in here. Oops. You can see the because sorry, another one just popped up. So you can see this black area right there, and certainly if I were to do longer than a 2-minute image, and I were to do 10 hours of data on this, I can really bring out the details in this little area here. It's obviously this is a noisy picture, but enough that you can see it. Oops.
Yeah. So one of the things that's interesting about M64 is this center region. The inner disk contains these dust lanes, and it's thought that this galaxy merged with another galaxy a long time ago, and you're seeing sort of some of the leftover material as it's continuing to be absorbed into the core of the galaxy. So it is well named that it got punched by in some way with some interaction with another galaxy in the ancient past. Dusty Reichwin. Oh, sorry. Flynn Bryan is asking what software I'm using. I'm using a program called Stellarium. Should be able to see. Oh, hold on. There, Stellarium, and I love Stellarium. It's free.
Yeah, Stellarium, and it's free.
Yeah. We actually use it a lot for our reporting in space news. We use it. I know, Dave, you pulled a lot of pictures out of it for doing the book. So
yes,
we use this
all
all
the
the time.
For most of the maps that I built were built originally starting with Stellarium. And then I kind of annotated what I needed to annotate. But
highly recommended. Giro the Hero is asking, how big of a telescope did Messier use when he cataloged all the objects that he found?
I believe it was a 3-inch refractor. It wasn't, and of course it suffered from chromatic aberration, which before they had the corrective lenses for that, like the crown and doublet lenses. Was standard for the day. So it's amazing you really saw anything. So I'm pretty sure I remember it was a 3-inch refractor.
I have M63 showing now. This is the Sunflower Galaxy. And just to go back to M64, there's M64, there's M63. I'm going to put them side by side so you can see them. There. And get rid of Dave Dickinson. There, down. So can you see both there?
Yeah, it looks great.
So there's the Sunflower there and the Black Eye there. Sorry.
And I will show that on Stellarium. So there's M64. So almost directly overhead. And then M63. And when these things are directly overhead, that is like the perfect time to view them. So both of them are actually fairly overhead.
So Roy and Stuart, what do you guys enjoy like the most to image? I mean, right now we can only really get galaxies. Do you like nebulae, or are you mostly galaxy guys at this point?
I have a medium size refractor. It's 980 milligrams. 980. It's higher. It's more heavy medicine than 980 milligrams. Yeah. It's a 980 millimeter scope in focal length. So I'm much happier in the wintertime. Not only because there's bigger stuff that I can see, you know, like the Pac-Man Nebula fills my frame kind of thing, but also because I can start imaging earlier. In the summer, at this time of year, I can't really get going until, 9:30, 10 o'clock at night.
I like the nebulas, the big nebulas.
Yeah.
In narrow band. I don't really like the color, the true color.
Yeah.
Because it's all red.
Mm-hmm.
So I like the narrow band so that I can get the false color in there, like the Hubble. They're really cool.
I think I mean, don't make me choose. Yeah, I'm not going to. I like them all.
Well, this stuff is interesting.
Yeah,
it's just my particular scope is just not really good at picking these out because these are much better off with like the 16-inch RC.
Yeah. The RASA is terrific for capturing images of this kind of thing.
So the next two images I have for you, Fraser, there's one up now. I'm starting into nebulas.
Oh, great. Okay.
And the nebulas are
the
bigger
nebula.
They are, the easier it is to get started. So for people who are interested in getting started with astrophotography, wintertime is easier because the things are bigger to see, which means everything needs to be wider and all your gear needs to be smaller, or doesn't have to be as big. And so it's the easiest way to get started is wintertime objects.
This is one nebula that's really good. I mean, it's a good summertime, and it's good in true color.
Mm-hmm.
A color camera, this is a really good nebula.
Yeah, I took some images of it, I think last week or 2 weeks ago, and it turned out great. It does want to be a bit of a longer exposure, but it's an emission nebula, and so you are getting these bright blue colors in the center of it. So I'll show you where this is. This is the Iris Nebula, and I really like it because.
I love the Iris Nebula.
It's
one of my favorites.
The nebula. So it's this nebula that's sort of pumping out all of this dark, sort of dusty material. And it's really where you're really close to the star is heating up this material to the point that it's actually giving off light. And so the rest of this material around it is the material that just isn't ignited. And it's just this center part that's actually starting to emit light. It's an absolutely incredible object. And you can kind of tell when you see these objects, when you see them in blue. Let me see here. So there's like some nebulae are blue and some are red, and then later on we'll see there's like the the Triplet that has part of it is in blue and part of it is in red.
Right, that's another one.
Yeah, because part of it is a reflection and part of it is an emission. Actually, wait a second. This is a reflection nebula. Sorry.
This is a reflection.
Yeah. So it's actually the material. So the you're seeing like the central star is shining on the gas and dust and lighting it up, but the gas itself isn't actually emitting light on its own. It's
right,
and that's why they call it a reflection nebula. And they're blue because the star itself is blue.
So the next nebula I have, I don't know what it is.
Okay.
It's one of these that's in my planetarium, but it is not labeled.
Oh wow. Okay.
So, I mean, there's a photo of it there, and I'm like, all right, I'll try that. And it turns out really good.
And you don't know what it is. Let's take a look.
Let's see.
Wow.
I needed better focus. This was in hydrogen alpha.
So you don't even know what it is. It's the mouse click position nebula.
Yes, it is. It's close to the North American Nebula if somebody wants to look it up, but I don't know what it is.
But it's not the Pelican?
No, that's where I was going.
Huh, okay. North America. So there's the North America, and there's the Pelican beside it.
It might just be a piece of the
Yeah.
big thing.
It kind of looks like the Pelican.
It's separated pretty far from it, though.
Oh, go back to your thing. Could it be
Here,
part
let's
of
do
the butterfly? You know, the
Let me do this.
is that solder, the big bright star there?
Can you see that?
I'm seeing you.
Yeah, okay, I see where we are. Okay, so we're off.
So the one up there around 1 o'clock, that's what I took.
That the one, the NGC 6995, or do you
No.
mean that purple box?
That's not what I took.
Yeah, the purple box.
I
Oh,
took
the
this
one up there.
here.
Oh, okay. So it's gonna be like over here. Yeah, it is around Saturn. Okay.
Okay, yeah. So that nebula is not named. I've taken it before. It's called like I've seen it different names, like the Butterfly Nebula, because if you look at a wide field, it looks sort of like a butterfly.
Oh, interesting.
Yeah.
Yeah, that's tricky. How do you take a picture of an object that doesn't have a name?
You mouse click it.
Yeah, the mouse
Wait,
click.
I have M51 up.
Oh, great. Okay, we'll switch over to that. The mouse click nebula. I like it.
You have to do in the olden days where you had to use what's called right ascension.
Actually,
and
I have a couple stacked up here too.
Yeah.
So,
Yeah.
so this is
That was my last stack. So if anybody's got any,
Stuart's got a bunch more. Yeah.
I got a few more coming up.
Okay.
So this is M51. So I've done better images of this, obviously, but this is 2 minutes. And actually, for 2 minutes, if you really get into it, you can really kind of see. Just if you ignore the noise, you can really you can see some good
Yeah.
detail.
Yeah, that
in
looks
there.
great. And so, David, you were mentioning earlier as an example of a galaxy collision. This is
Right.
one. You've got the larger galaxy is gobbling up this smaller galaxy. You can see this tidal tail of material
on
that
here.
connects the two galaxies together.
Galactic cannibalism.
Yeah, exactly. Classic.
I love the
This
term.
is-
Starchface on
This
Twitch
is-
is asking, can you explain why are things seen in the winter bigger? I don't think.
Oh, I
things
know
are-
I know what he's asking. So the reason why is in the winter we're looking right up into the Milky Way, and everything in the Milky Way is a lot closer to us than other galaxies.
Yeah.
And so the other galaxies, when we're imaging like we're doing now, they're millions and millions and millions and millions and millions of light years away. But in our galaxy, we're talking maybe 10,000 light years away, or 5,000, or
Right,
whatever.
right.
It's they're much closer, so they appear much bigger to us. And also, since we're looking in the galaxy, we see a lot of ionized hydrogen, and so we get to see a lot of wispy clouds and stuff. It just for those of us with wider fielder scopes, it's a prettier time of year. Now the galaxy hunters, the guys with the big scopes, they love picking off these tiny little galaxies, and
Yeah.
they're wonderful. I mean, just look at atom block stuff,
Yeah.
and it's fantastic. I just can't do it with my scope.
And the light pollution filters work a lot better with nebulae just because of what they're made of, whereas a galaxy is a lot more white light, a lot harder to cut through light pollution than a nebula.
Yeah.
So say our home is in the Orion Spur, so that's actually the constellation Orion is in that direction.
Yeah.
Like you said, we're looking at that closer part of whereas in the summer we're looking actually toward like the Scutum Centaurus arm, that's one arm in, but a separate spiral arm, if that makes any sense, from where we're embedded.
Conwu was asking how far away is the galaxy. In general, these galaxies are in the tens of millions of light years, so you can be pretty safe to say they're all anywhere between 20 and 50 million light years away. Whirlpool specifically is 23 million light years away. This is M101, right?
Correct.
The pinwheel.
Yes.
And it is 21 million light years away.
This is one of my favorite galaxies.
Yeah, this is terrific.
It's once you get color on it, it's just really, really pretty. It's you can just see a lot in it, and it's nice and big, and it just I love this guy.
Javier Rodriguez is asking, hey guys, question, are there any peculiarities of astronomy near the equator? Greetings from Venezuela.
I could definitely add to that.
Yeah, sure, David.
So one of the things as you approach the equator is that the poles of the Earth will be towards your horizon, and so the entire sky is visible, both the northern and southern hemispheres of the celestial sphere, the sky at night, and that also means that unlike when you're closer towards the polar regions, sorry, that's my microphone, you don't have any parts of the sky that are what are called circumpolar, which means that you can see them year round. So for me, where I live at 40 degrees north latitude, the place around the North Star Polaris, it just kind of rotates around that North Star. But as you go to the poles, that would actually be directly above you. So when you're at the whole sky is circumpolar.
Yeah.
When you're at the equator, none of the sky is circumpolar. It's kind of cool.
Yeah. Yeah. Same thing for me. I'm at 49. And so for me, I can see the Big Dipper all year long. It just does this. It just goes around and around Polaris.
Oh, that's not the right one.
Yeah, so technically from the equator you see both hemispheres.
Yeah.
Only the poles are pretty low. The belt of Orion is very close to the celestial equator as well.
So, I mean, each part of the world has its advantages and has its disadvantages. We get to up in the northern hemisphere, we get to see all of these really cool objects that are close to the celestial pole. We can see them, while the people who are in the southern hemisphere can never see them, but they can see the objects that are close to the southern celestial pole, like Alpha Centauri and things like that. But if you're near the equator, then you get to see everything. You get to see both some of the stuff from the north and some of the stuff from the southern hemisphere, but you don't get as the closer it gets to the poles, then they will always be low on the horizon for you. So you've got your own sets of objects. I mean, each part of the sky, each place on the Earth just gets a different view.
When the length of their day, is also around 12 hours as you approach the equator.
Yeah.
Whereas if you're at the North Pole, you can have 6 months straight of darkness.
Yeah.
So, that plays a role in your ability to do astronomy. You have a window where I live. We were talking about earlier, I think Stuart said something about just the time we have to start at night is really late.
Yeah.
Summertime, you only get like 4 hours of astronomy in before it starts to get light again. Whereas if you're at the equator, you get 12 hours all year long.
Yeah, it doesn't vary as much.
So we got Bode's galaxies here.
And Fred, you want to tell the story on this? Do you remember that?
Of course, I'll be bringing it up every week. Yeah.
You tell the story on this.
Yeah, well, yeah. David, like I said, Dave and I have been telling the story each week. But over on the right there is that's M81 and M82. M82 is the one that's on the right here, and it is well known for being a galaxy that can have a lot of supernovae in it. And in one star party several years ago, one of our participants was making that very note while there was a supernova in it, and we didn't
streaming
realize.
A supernova live.
Yeah. And we didn't know it.
And so
the next day, I saw it in the news when it came out, and I'm like, weren't we observing it?
Weren't we looking at that galaxy? And so you could see, like when you look at M81, which is the one that's on the left there, all those stars that are in the disk of the galaxy itself, any one of those would look identical to a supernova. Right, so some of those could be stars that are in the foreground, and others could be supernovae. And
we're saying some observers kind of know I know on M51 that there's one star right off the heart of it that is a false supernova. It's a star in our galaxy,
And so
they know the patterns.
And so each week, I guarantee you, Dave Dickinson is double checking these galaxies to make sure that he's, that he's not missing it again. Yeah.
Yep.
So for people who are following along, all of the photographs that are being taken are being dropped into a Google Drive folder, and I think Nancy is sharing the location
Yeah,
of that Google Drive
I haven't done
folder.
it yet. I've been.
You've been busy. Okay, all right. Well,
I will dump them. I promise.
Yeah. So they will either already be in there or they will be dropping in as we go.
Yeah.
Yeah.
Let's see.
Yeah. And so they are all publicly accessible, and go ahead and turn them into your phone's screen. And over the course of the week, we'll probably throw more pictures into it, and then we'll we'll start up again next week with the new images for the next star party.
And the images won't be that different because it's just 1 week.
It's 1 week. I know. It's so like over the course of the entire year, everything changes, but over the course of 1 week, it's
okay.
fairly
Oh, this
subtle.
is cool.
Yeah.
Yep.
That's the owl.
This is better than I thought it was going to be. So I had no idea how this would turn out. This is the owl. You can shoot. There we go. So you can kind of see why it's called the owl, because you see the little owl's eyes right there.
And I wonder if that central star is the actual central star of the.
I don't know.
Yeah.
But normally, I've imaged this before, and it's blue. It's a nice deep kind of bluish green.
Some color.
Yeah.
There's a galaxy nearby that one.
Yeah, so the central star
is
a 14th magnitude star that has reached the turning point in its evolution where it has become a white dwarf. So it has about 50% of the sun's mass and about 140, somewhere between 40 and 148 times the brightness of the sun, and a temperature of 123 Kelvin, 123,000 Kelvin.
Yeah, I should have framed this a little bit better, because there actually is a galaxy right off frame.
Oh, yeah.
Maybe next week I'll try to find a better plate solve for this. But and once the one time when I did image this, I did it over like 3 or 4 nights. Right after I did that, a comet passed right in between those two.
Wow.
Yeah, and I, of course, missed it because I'm an idiot.
That's incredible.
Fraser, was it you who was saying about our sun not turning into a white dwarf?
There was a study a few years ago that had come around on the news that we were talking about. Yeah, researchers were saying that there's some controversy whether we would become a planetary nebula.
So the minimum size of the star to actually become a planet, to create a planetary nebula at the end, needs to be possibly a little bigger than our sun, so that it can go through a pretty energetic red giant phase and blast off all those outer layers. And
we almost need to do like things that we talk about at star parties that
are wrong,
may or may not be true, are wrong.
Yeah, exactly.
That's what this job has taught me, that everything I say at a star party is basically wrong.
Yeah, and
what would it do? It would just kind of simmer down and just kind of die out.
Yeah, just fade away. Yeah, so just the reason you get this crazy shape with the planetary nebula is part of it comes down to the magnetic field of the star. So as the star is rotating, and it has this magnetic field that's sort of turning through this stellar material as these outer layers are being sloughed off. And that's why each one of these different planetary nebula has a completely different shape, is because it's sloughing off this material and it's being whipped around as the star is rotating, and as it's losing material, it's speeding up and getting and like whipping around inside of it, almost like a blender. And so it depends on the actual nature of the star itself and the size of the star, on how much material it actually sloughs off and how much it will turn, sort of twist up into this kind of a shape. And so the thinking goes that they're not entirely sure now that our sun is big enough and has the right characteristics to create this. And so the thing that's kind of amazing about this, right, is that you are staring at the very middle. You can actually see that central star. It is a white dwarf. And so, a star like our sun, the surface of the sun is about 5,700 Kelvin, which is hot, right? About 5,800 Celsius. But inside the middle of the sun, you're looking at temperatures that are tens of millions of Kelvin. And that's what it takes to be able to actually create fusion. And when the star dies and it blasts out all of those outer layers, essentially the core of the star is all that remains. And so now the temperature that you see is hundreds of thousands of degrees, because you are seeing the naked core of this star. It has blown away all the material and what's left, but now it doesn't have the pressure to keep doing this fusion, and so now it just has to cool down to the background temperature of the universe, and that will take tens of billions, trillions of years for it to cool down until it's impossible to see.
I have a really kind of cool demonstration that I do with my students where we take magnets and I cover them in Velcro, and if you kind of slide them gently towards each other, they're north to north or something, they'll repel.
Yeah.
But if you throw them fast enough and hard enough, they'll stick, and then they'll stay together because of the Velcro, which is acting like the strong nuclear force.
Oh, interesting.
In a fusion, it really kind of clicks for them. It has to overcome the Coulomb force, I guess it is, and as soon as it does, as soon as you can get them close enough, because the strong nuclear force only acts over about the width of an proton.
Yeah.
And then it sticks just like the Velcro does.
Oh, that's amazing. What do we got now, Stuart?
This is M100.
Oh, great.
And
I don't think I've ever
friends.
seen image of this in the party.
Yeah, this and some friends. And I keep getting the star trailing, so I'm going to have to investigate that this week because it's pissing me off. But it might just be because I'm sitting next to the scope and I'm bouncing around.
Right, you're just so excited.
Because
I was going to say, let's look at M100, and then I sort of backed out on Stellarium here, and it's just lost in the galaxy pile. Look at that.
Oops.
Again, just so many galaxies. It's just incredible. There's just one galaxy.
I've got one for you, Fraser.
All right. Ooh, the elephant trunk.
That's actually not.
No.
Oh.
No. This is NGC 6823.
6823.
I don't think anybody's probably ever showed this.
No, that's why I have no idea what this is.
What?
You'd have to look it up on Wikipedia.
Yeah, hold on. No, I got Stellarium's got you. But
Wikipedia
it has no idea what it is.
Database.
That's so funny. So
I picked it because it had the nebulosity in it, but it also has an open cluster.
That's really cool.
Yeah, because I think that it's a cluster with nebulosity.
Oh, nice find, Roy. This is amazing. How long of a exposure
That's
did you do?
2 minutes. 2 minutes hydrogen alpha.
Okay. Oh, I love it.
Are you binned at all? Or is this unbinned?
That's 2x2 binning.
That's 2x2 bin. Yeah, that's great. So this is a fairly rare kind of thing to be able to see. So you've got this open star cluster here, which is the remnant of a star forming region, and then it's embedded within a larger part of nebulosity. So I wonder if this is the leftover nebulosity from when it was a stellar nebula.
Do you guys know what is the closest open cluster?
No.
I do, but go ahead.
The guy that writes books. Yeah, I do.
Yeah.
What is it, Dave?
I would say the Hyades.
Yeah, that's what I was going to guess.
Okay, so the Hyades is I thought number 2. I had to have to look at where I found this, but the Big Dipper.
Well, it's a moving group.
Is a moving group. It's just an association.
Yeah, the stars in the Big Dipper are actually
it
dramatically different distances. So they're not.
Yeah.
Okay.
Yeah, they're in very different distances from each other.
It's the Hyades for sure. Then.
Yeah, the Hyades is the nearest open
but
cluster. And
But there is an association called the Ursa Major Moving Group. Most of the stars in the Big Dipper are part of that. They're sliding by. Our sun isn't a member of that group, but they're kind of sliding by us right now.
But if you look at the Big Dipper from any other direction, they actually aren't that closely connected.
Yeah, now that you say that, I'm thinking about models of that. Yeah.
That's fantastic, though. This is I love it when we get an object that I've never seen before, and this is one of them. That's so great. Now I
want to find stuff that we haven't seen, but it's a little hard.
That little projection, that little finger that's coming up, that's generally where at the end is where a star would be formed and evaporating gaseous globule, right?
Yeah, it kind of looks like the pillars of creation, right?
Right.
Yeah.
I would love to see this in a higher, like a longer exposure.
Yeah.
It might be one that I'm going to add to my list.
Yeah.
Definitely.
So it was NGC 6823. I want to see. Yeah, I'm going to see if the internet can show me a picture. Oh yeah.
I think visually it's quite faint. Well, the cluster you would see,
It's
but the nebulosities
color to it.
Yeah.
Yeah, I'm seeing a couple of pictures on the internet. The cloud sculpting star cluster. Yeah, there's a really good one on APOD from Donald Wade took back in 2014. And you can really see. Yeah, definitely you're going to want to take another crack at this longer, Roy. You can pull quite a lot out of this image.
Can you pull up what it looks like on YouTube? Because I don't think we saw what you were looking at.
What the actual,
like an image online, or
well, I don't want to share. Yeah, I don't want to share. I don't want to violate
That's
someone's
fine.
copyright. So
okay.
So I'm gonna see.
Didn't know if that was possible.
So there's if I can't see one that's just like completely open source. So
I just went to Wikipedia.
yeah, if you do a search, I don't know if someone's got
I'll
it
do
in
my own.
Wikipedia. Yeah.
I thought like the Hubble images and all that were open.
They are, but
Sometimes with APOD you have to be careful because there's
right.
a lot of copyrighted images on it.
Yeah.
It's the only NASA source that's
so I've got an image here.
copyrighted.
Yeah, I've got one here. Let me see if I can share this one. So this one comes from Jeff Johnson. I'll share this image so you can just see what it should look like here. So this is like someone's taken a lot of time. This is the one on Wikipedia.
Oh wow.
And so you can see here, this is the region that's pretty much on the screen, and there's that trail. But if you do a search for this NGC 6820 on the internet, you will see a lot of pictures that are pretty amazing. So yeah, I highly recommend.
So it's way bigger than
it's a much
frame
bigger.
here.
Yeah. So that central part that you're getting here, that's the bright core of it, but it's actually it would take up your whole screen and more. Like, it's an enormous object. So someone was asking, I think was Doug asking, how come there's nobody from Antarctica? I would love to have an astronomer in Antarctica. The view from Antarctica is like the best place in the world, but
I'll go.
Yeah. Okay. Yeah. Dave will go.
I could check all the continents off then.
Yeah.
I'm working on.
So Tanya Waters is asking, how do I know if the image is a new one? I don't know. I have I remember all the objects that we've ever looked at. You see these sky objects that become very familiar to you, and so there are thousands, but the top 100 or so you see a lot. And then
so somebody can go through all the virtual star parties and checklist off everything.
Yeah, everything. I mean, if you go all the way back, we've seen Pluto, we've seen Uranus, Neptune, we've seen we've seen all the planets, we've seen comets, we've seen asteroids, and we've seen almost every deep sky object. But But I mean, I think now we've got much better setups. I mean, we're on episode 5 of the next generation, and we've got much better setups now. So, Linda is saying it looks like a Bok globule. Yeah, I think that is a Bok globule.
Yep.
They're little nuggets of star formation. But that's just terrific. Did you have another picture, Stuart? The Cat's Eye Nebula? Yeah, that's my experience with the Cat's Eye Nebula as well.
M57 should be like 30 some degrees above the horizon now, and M29 is starting to get close to like 20 some degrees.
Yeah. So I think we'll wrap this up in just a few minutes. I'm not sure how how's your list coming, Stuart? You're muted. I can't hear you.
Sec.
Oh, there we go.
1 sec.
Yeah, we hear you now.
Okay, I'm working on getting the ring right now,
Okay.
but we can save it for next week.
No,
if you
let's
I've got
get
it.
the Ring Nebula.
Oh, you got it. Okay, great.
Okay, all right. Roy got it. All right.
Great.
Yeah, I'll zoom in a bit. It's actually in hydrogen alpha.
That's a hydrogen alpha of the Ring Nebula. Okay.
Yep.
And this one in Lyra is always easy to find. I can even see it with binoculars, just,
Yeah.
as a little smudge.
But
it's easy because it's in that little parallelogram, like right between two stars.
Yeah, it's a very. I'll show you the ring again. If you have a pair of binoculars, you have a telescope. Ring Nebula is a very easy object to find. Okay, I gotta just. He says, and having to search for it. So if you know Lyra, like Vega is like the brightest star in the sky, and when you find Vega, one of the brightest stars, like in the summertime, it's the brightest star in the sky, and then you can find it has this little parallelogram poking off the side of it, and again, halfway in between these two stars is the Ring Nebula, which I like.
One of my favorite multiple stars to show people is up there is Epsilon Lyra, the double, where it's actually 4 stars.
Yeah. And
nice,
you can just show that what looks like one star with your eyes, 2 stars like in a pair of binoculars, turns into 4 stars in a small telescope.
Yeah.
Fantastic, guys. Well, I think we should definitely wrap things up. I know it's bedtime for David and David for sure. It's so late over on that side of the.
I've got an early morning phone call too. So
yeah.
It's Monday here.
So Stuart and Roy, that was great. You guys were just tag teaming those objects at high speed. That worked. That worked like a charm. Good job. So thank you again. Great to have you guys back on the show. And
glad to be back.
Yeah, and you've definitely covered me not having to open up the telescope in a windstorm. And I was able to focus more on explaining what we're seeing. So that's always it's always a pleasure. It's
I'll data dump all these subs into the drive, and people can play with them.
Awesome. Okay, great. Yeah. So once again, if you want, all the pictures that we're taking are going to be dropped into that folder. We will be back again this same time next week as we get closer and closer to the summer solstice. But thanks everyone for watching, both on YouTube and on Twitch. Thank you to all of the moderators who have been copy pasting all the questions, and thank you to Nancy for organizing the whole show. A big amount of the thanks goes to Nancy Graziano, who has been organizing behind the scenes to make this to really help bring the Star Party back and make it a much more professional operation. So we couldn't do this without you, Nancy. All right. Everybody, we will see some combination of you next week, and hopefully I'll have a telescope again.
Awesome.
Thanks, everybody.
Okay.
Thank you.
Thank you.
Right.